This is lesson 1.2 for Secondary 2 Honors, and we are going to be proving properties about triangles today. So we're going to start by talking about things that we know about triangles and some definitions and things, and then we're going to set about proving some things about triangles. So at the top of your notes, you see that we have some different ways to classify triangles. And so there's two different ways to classify them. One is by their angle measures, and so these words are they should be familiar to you. So we have acute triangles, obtuse triangles, and right triangles, and those are based on the angles that are within the triangle. So an acute triangle is where all of the angles are less than 90 degrees. So, you have something that's, 60 and, 70 and 50, and so that would be an acute triangle. An obtuse triangle is where one angle is 180 degrees. Now, or more than 90 degrees, sorry. If you think about it, you can't have more than one angle that's more than 90 degrees, because you can't even have two angles that are 90 degrees, because then what would you do for the third angle? So it would be one angle is obtuse, the other ones would have to be acute, but that's what an obtuse triangle is. And then a right triangle is where one angle is 90 degrees. Okay, so that's according to their angle measure. And then the other ones you may not have heard since maybe elementary school, but there's scalene. We've heard of isosceles and equilateral more recently, I guess, but scalene is where none of the sides are the same measure. They're all different lengths. Isosceles is where two of the sides of the triangle are congruent, and then an equilateral triangle is where all three sides are equal to each other. Now, there's some different things about these different types of angles that we're going to see, and we're going to use those definitions, and then we're also going to prove some things about them. Like, there's some interesting things about isosceles triangles, and there's some interesting things about equilateral triangles that we're going to prove, but before we get there, we're going to do some other things with it. So the first one that we're going to talk about is the Angle Sum Theorem. So it is a theorem, which means we can prove that this is true. And the Angle Sum Theorem, you're actually familiar with it already, and what it says is that it says in any triangle, the sum of the three angles equals 180. And so we know that that's true because there's a theorem. Now we can prove it, but in the meantime, until we have to prove it, we can use it. So we can use this to write an equation, and so if we were doing this in class in a regular year, what I would have you do is I would have you work together with a partner to solve one of these and then work individually. So you can kind of do that how you want. But let me just do the group one with you, and then I'll have you do the individual one, and I'll just write the answer up. You can check any of these notes online if you're not sure about how I did something. So for the group one, let's do that one. So to solve for x, so I'm going to take these three angles right here, and they're going to add to be 180. Why? Because they have to. That's what the Angle Sum Theorem says. So I'm going to write an equation that gives all of those to be 180. Now here again, when you're showing this on your paper, you need to show writing that equation. You can't just do it all in your head or punch some numbers in your calculator. That's not showing me what you're doing. So I expect that you're writing this down and that you're showing how you're getting these numbers, okay? So -1 plus 6 plus 55, you can just write that that's 50, that's fine, but I have to see the steps that you're following to solve your equation. Subtracting 50 on both sides, again, I don't have a problem if you want to just do that, okay, that's fine. And then x is equal to, and then you're going to divide, wait, I think I did, 5 plus 55 is 60, not 50, 60, and so this is 120. And then so x is going to be equal to 8 when you divide both sides by 15, and so that's how you're going to do that. So on the individual question to the right, you're going to do the same thing where you set up an equation and you're going to solve for x. So you can pause this and then turn it back on and see what the answer is. If you did this problem right, you should have gotten that x is equal to 10. Okay, and then it also says find the measure of angle A, and so angle A is this angle right here, so 4 times 10 plus 1 equals 41, so the measure of angle A equals 41 degrees, and so those are the answers to that question. Okay, now the next section, it's the Isosceles Triangle Theorem, and I'm actually going to erase some of this stuff so it's not in the way. The Isosceles Triangle Theorem, it's true for isosceles triangles, so remember that that's where you have two sides that are the congruent. And what it says is it says that the base angles are congruent. Now, base angles in an isosceles triangle are the two angles that are opposite the congruent side. So in this one, we have these two congruent sides. The angles that are opposite them, those are the base angles. And so what the Isosceles Triangle Theorem says is it says that in an isosceles triangle, these two angles would be the same. So we can use our algebra then to solve for x. So we could say 20x plus 4x plus 6 plus 4x plus 6. Now you also could write that as 20x plus 2 times 4x plus 6. And that's equal to 180. And so you can solve that. So however you want to do that, I'm just going to go ahead and do the first one so I have the space. But I'm going to have 20x and 4x and 4x. That's 28x. And then 6 and 6 is 12. Equals 180, and then I'm going to solve that. And so I'm going to subtract 12 from both sides, and I'm going to divide both sides by 28. So get my calculator, and I find that that's x is equal to 6. Okay, now for the individual one, this one's a little bit harder, and so I'm going to kind of walk you through a little bit, but I'm not going to do everything for you. But it says how many degrees is the angle marked x? So I'm looking for this one right here. So I know that whatever that one is, it's going to be the same as this one because base angles again. I do know that this angle right here is 90 degrees, but that doesn't mean that it's evenly split either. I also know that these two angles are the same because they're base angles. Okay, so from that, so I do know that. I also know that if this is 109, this one has to be 71 degrees because this is a linear pair. So I use all of these things that I know. So I know that that's 71, so this has to be 71. And 71 and 71 is 142. And so 180 minus 142 is equal to 38. And so this right here has to be 38 because that would make the triangle. Now I know that since this is 90 degrees, I would do 90 minus 38. And so that's going to be 52. So this is 52 degrees. So since we said at the beginning that this angle and this angle are the same, I know that x is equal to 52 degrees. Okay. I said I wasn't going to do the whole thing, but there you go. All right. So those are the Isosceles Triangle Theorem and the Angle Sum Theorem. So you need to remember that. And so on your vocabulary sheet, there's a place for you to write something about that. And so make sure you write what that is. Now the next one is called the Mid-Segment Theorem, and so let's talk about what a mid-segment is. A mid-segment is where you have a triangle, and let me just see if I can draw this for you. Triangle, and you have the midpoint of one side and the midpoint of the other side. So we have those are equal and then those are equal. And then you have a segment that joins those midpoints. That's the mid-segment. And so the mid-segment theorem says that in a triangle, the mid-segment is parallel to the third side. And not only is it parallel, but it's half the length. Okay, so let's just do an example real quick. So if I have a triangle and this is a midpoint and this is a midpoint and I have this mid-segment right there, and let's say this is x. I know that this is parallel to that side, okay, because it's a mid-segment, and so that's one thing I know. I also know that this is going to be 2x, okay, so I can use that like if I know that, you know, say I'm told that this bottom one is, 22, then I know this is 11. And I also, because they're parallel, I would know something about the angles. Like, for example, if I knew that this was 27 degrees, I would know this is 27 degrees because they're parallel, and that would be a transversal, so corresponding angles. So there's a lot that I would know because of the mid-segment theorem. Okay, so let's go back to those problems on the mid-segment, and let's look at some of these examples. So again, let me erase some of this other stuff here. Okay, so in this example right here, okay, we've got this triangle. And basically it's just showing, sorry I can't zoom in, it's just showing mid-segments. Like MP is a mid-segment and it's parallel to DE, so those are parallel, and MP is half of DE. And then we also have some other mid-segments, so we can say that MN is parallel to CE and it's half of the length, and so on and so forth. And so then I've got down in this lower triangle, this is 5, so this would be 10. Okay. So in this group 1, it says write an equation to solve for x. So I know that this is a midpoint because I can see that it's equal there. I know that this is a midpoint, again, because I see that that's equal. So I know that this times 2 is that. So 2 times x plus 2 equals 3x minus 8. And I can solve that for x. Okay, so you can go ahead and solve that for x, but what you're going to get is you're going to get x equals 12. So I'm just going to leave that for you. Now I want you to do the individual one and see if you can come up with the right answer for that. So again, you look at, you've got midpoint, so how do you set up your equation to solve that? So pause the video and see if you can come up with the right answer. Okay, if you did this one right, you should get that x is equal to 6. Now, if you're not sure about setting that up or anything, you can always look at my notes for any of these. I've got it written out, but I'll just tell you, you're going to do 2 times x plus 2 equals x plus 10, and then you're going to solve that, okay? All right, now the next one is an exterior angle theorem. So again, let me go to my blank paper, and I'm going to show you what the exterior angle theorem is. So the word exterior means outside, and so if I have this triangle, and I'm just going to do a nice, pretty triangle for now, I've got this length that I extended right here. So like if this is A and B and C, the point off of A, I can extend that side. I could also extend that one as well. And I can extend any of my lines to show. But these angles that are formed then, like right here, that's an exterior angle. This is an exterior angle. Exterior angle, exterior angle, exterior angle, exterior angle. Please notice that this one is not an exterior angle. Okay, an exterior angle is adjacent to the angle in the triangle, okay? And it's a linear pair with one of the angles in the triangle. So that's what an exterior angle is, all right? Now there's really cool things about an exterior angle, and again, it's a theorem because we could prove this, and I believe that we're going to have an opportunity to do that at some point. So let me just kind of erase some of these markings here. I'm going to erase some of the extra points, but let me just show you about an exterior angle. If this is, let's just say this is 50 degrees and this is 40, no, I don't want to say 40 degrees. Let's say 70 degrees and this is 60 degrees, okay? I know that this one would have to be 120 because, again, linear pair, okay? And so what do you notice if you add up 50 and 70? It's 120. That's not a coincidence. Okay, if you were to go over here and say this angle right here, this is going to be 110 because 110 and 70 is 180. What do you notice if you get 50 and 60? It's 110. And so that's how exterior angles work. This exterior angle is the sum of what are called the remote, because far away, remote interior angles. Okay, so that's something about an exterior angle theorem, and we can use that to help us find things that we don't know. And that's really the point of all of these, is it just helps us have a way to find things that we don't know and learn how to use those things to help us. And that's really one of the main points of math, is we have this information, we figure out how to solve problems with it, and that's just a life skill. So if we look at the examples box, this is 110, this is 61, and I don't know, question mark. So 61 plus x is equal to 110. You can solve that. That's really easy. The one down below it, here's my x. X is equal to 110 plus 32. Easy. Okay, so look at the group one. This one's a little bit harder. It has a little more algebra in it, but this angle is the exterior angle. So 23x plus 3 is equal to the sum of the two remote interior. That's not a very hard equation for you to solve. You can solve that one, okay? So go ahead and solve that one. You should get x equals 4, so just make sure that that's what you're getting. And then I want you to pause the video and do the individual one. Okay, and the individual one, if you did this right, you should get that x is equal to 5, and it does say find the measure of the angle, so the measure of this angle, I guess, right there. So 12 times 5 is 60 plus 4, that's 64 degrees. And then 14 times 5 is 70, so that's those angles. And you could say, well, 64 plus 70, it is in fact 134. So that's how you would do that. Okay, now the next thing that we're going to look at is we're going to look at proving. Okay, so proving the exterior angle theorem. And so again, that means I'm going to prove that angle 1 plus angle 2 is equal to angle 4. So I'm going to prove that angle, the measure of angle 1 plus the measure of angle 2 equals the measure of angle 4. That's what my last step is going to be. So measure of angle 1 plus measure of angle 2 equals measure of angle 4. I don't know why or what the reason is going to be for that, but I know that that has to be the thing I'm proving. I also know, what am I given? I'm given a triangle. Triangle with interior angles, angle 1, angle 2, angle 3, exterior angle 4. Because that's given to me in the picture, and there's no other reason for that. Okay, so how do we prove that then? Well, think about, we're trying to get to be something as 180, or sorry, not 180, but there's things that are adding together. So what could I add together that I know something about? Well, I know that angle 3 plus angle 4 equals 180. Why? Can you think of the reason why without me telling you? Okay, hopefully you came up with it's a linear pair. Okay. I also know that angle 1 plus angle 2 plus angle 3 equals 180. Why? Because of the Triangle Sum Theorem. Okay, so I know that. So I also know, since this is 180 and 180, I would know that angle 3 plus angle 4 is equal to angle 1 plus angle 2 plus angle 3, sorry. Okay, so that could be my step 4. And why do I know that? Can you figure out why? Why would that be? What did I do? I substituted. Instead of 180, I put in something that was equal to 180. So that's substitution. Okay, the next thing, keep in mind where I'm trying to go. I'm trying to have angle 1 plus angle 2 equals angle 4. Well, if I subtract angle 3 from both sides, I have that. So this is actually step 5, because subtraction property of equality. I subtracted angle 3 from both sides, and I've got angle 4 is equal to angle 1 plus angle 2. And so there you go. That's proving the exterior angle theorem. So proving a theorem, it sounds hard. It doesn't have to be. And it all comes down to how good are you at kind of seeing the end and where you're trying to go, and then just figuring out a path to take. And again, as I said in the last lesson, it doesn't have to be exactly this layout for this proof. Just basically I'm looking for, do you understand the path to get there? Can you find a path that's legitimate, giving your reasons why? Okay, the proof of the Angle Sum Theorem, I'm going to do that in a different video. That's quite a bit harder, and so I'm going to come back to that later. Let's come down to the proof of the Isosceles Triangle Theorem. Okay, so this one's also a little bit harder, and there's different ways that you can do this, but I'm going to just show you how you would prove this. And for some of these proofs, you're going to have to know how to do them. Like the exterior angle theorem, that would be something like, I might ask you to do that on a test or a quiz. Something like the Isosceles Triangle Theorem, I wouldn't ask you to do this one completely solo on a test or a quiz. I might have like a multiple choice or a fill-in-the-blank proof where you have to figure out like what would the reason be for this or something like that. But I'm not having you do really, really difficult ones on your own, okay? But that doesn't mean that on your homework you don't have to try them, and on your notes we're not going to try them. It means that I may not expect you to do it 100% on your own on the test. Okay, so the Isosceles Triangle Theorem says, remember that it says that if you have an isosceles triangle, the base angles are congruent. So I'm trying to prove, so I'm just going to write prove, angle A is congruent to angle C. That's what I'm trying to prove, okay? So my last step will be angle A is congruent to angle C. I know that that's my last step. Okay, so let's start with what I'm given. I'm given triangle ABC, where AB is congruent to BC. And that's given. Okay. Now with this one, it's like you look at this point and you're like, okay, well, what do you know? I mean, you know that they all three add up to be 180, but how does that help me know that those two are congruent? And you're really kind of stuck here. And so this is why I'm telling you, like, this is how we would do this proof. You are going to, for step 2, you're going to construct an auxiliary line. Now, you don't actually have to construct like with a compass and stuff, but we're going to use a construction to make a line that's not already there, and we're going to use that in our proof. So what we're going to do is we're going to construct a line that is coming from B, and it's going to be constructed so that it is perpendicular. Okay, so we're going to construct BD to be perpendicular to AC. How do I know that it's perpendicular? Because I'm constructing it to be perpendicular. Okay, that's what I'm doing. All right, now the next thing we're going to do is we have to use some things that we learned about last year. So last year we did some congruence theorems, if you'll remember, and like side angle side and side side side. We did some of those, and so that's kind of where our brain needs to go at this point. And so what we're going to do for step number 3 is we're going to say that we're going to call this D. So we're going to say BD is congruent to BD. Do you remember why the reason was for that? Do you remember why we said that when we did that last year? It's called the reflexive property. Okay, so I know that. I'm going to erase these little green marks because I don't know those right now. I'm trying to prove that. Okay, so what else could you come up with? Can you come up with anything else? Now I know that this is 90, I know that this is 90 degrees right here because I constructed it to be that way. And so that makes this a right triangle. And if you remember, there was one theorem for congruence that we learned last year that is just for a right triangle. We very, very briefly talked about it. I'm going to tell you, but then I'll tell you another way you could do it. Do you remember the Hypotenuse Leg Theorem? And that says in a right triangle, if the hypotenuse and a leg are the same, then those two triangles are congruent. So you could actually use that to prove that this triangle is congruent to this triangle. You could use hypotenuse leg. Now, if you didn't think of that, what you could do is you could say, well, since this is 90 degrees, this one has to be 90 degrees, so you have another angle. Okay. The problem you might see now is that then you would have angle side, side, and we know what happens there. So that's kind of the bad news for that one. So you're going to have to kind of think of some other ways. And so there are some other things that you can do, but really hypotenuse leg is going to be your best bet for this one. So for this one, we're going to say that triangle ABD is congruent to triangle CBD because of hypotenuse leg. Now, since they are congruent, that means that this is congruent to this. Do you remember why? If two triangles are congruent, why are their corresponding parts congruent? Do you remember CPCTC? Okay, so that was something we learned last year. All right, so that's how you would prove the isosceles triangle theorem. I'm going to go to a different video to prove the Angle Sum Theorem, and so you can check that one, or you can just look on the paper, whichever you prefer. So in your homework, you're going to have to do some various proofs and some finding missing parts and pieces. And so again, using the properties and the reasons why, you're not really going to see anything that's brand new. It's going to be like using the same reflexive property or congruent triangles or exterior angles or things like that. So just look for things that you can use there. Remember that this is a learning process. It's a puzzle. You're figuring it out. You may look at the answer key to help you. Your homework is just a learning process, and I want you to learn it. And if you have questions, I want you to ask.